Okay, good. We're recording now. Okay. So that's that about FastX. So I'll show you a couple other ways to log into these machines if you don't want to use FastX. So we are connecting to these machines over what's called the communication protocol, known as SSH. So this is secure shell. So a secure shell is a connection that is encrypted. So some nefarious person out there on the network can't snoop on your traffic and see what commands are you typing, what data files are you looking at, and so on. Your connection with that remote system is secure, just as when you log into your bank online and that connection on the web is secure, okay? So this is a secure shell. So there are several different programs that I list here that you can use on Windows. So if you go to either of these links, this one for PuTTY, P-U-T-T-Y, or Xshell, those are both SSH client softwares that you can download and install on your Windows machine to run. So if you don't like using FastX, you can go grab one of those. I think they're both free. And you can simply fire that software up, just like FastX, where you're telling it what host or what machine you want to connect to. These programs will prompt you, what machine do you want to connect to, what's your login at that site, what's your password on that machine, and then it will establish the connection, okay? Just as FastX has done for us. If you need to do a lot of heavy graphics work, there's a program called Xming that does a very nice job. And Xming is a tool like FastX that allows you to log into a remote machine, but also display graphical stuff back on your local computer. So those are nice alternatives for Windows users. For Mac users, Macs have a completely different software environment, and Mac provides a program called Terminal. So if you're on a Mac, you can open your Applications folder. In there, there's a folder called Utilities, and there's a tool there called Terminal. And so Terminal looks like this. When you start it up, it just creates a window logged into your local machine. And then you can execute the command SSH. You give it your login at. Okay, so it's very much like using FastX. You give it your login and the machine where you want to connect. It prompts you for a password. Yeah, so in this case, I have a CHPC account, so I'm using my unit as my password, as my login, I should say, and the password that goes with my unit. So the same password I use for all the other university sites, okay? And it lets me in. And so this is exactly the same as connecting to a FastX session like this, connecting to a window, all right? So for today's session, I'm going to use this window here. One reason is because I can blow up the font so that everyone can see in the back of the classroom. But that's really the only difference. That, you know, we will be using essentially the exact same tools to do this. Okay. Okay, so a cool thing about all of these tools is you can open up multiple windows. You're not restricted to a single window logged into that machine. So what I will frequently do is here I am working on Linux class. I can now open a new window. I can SSH in there as well. Okay, give it my password there as well. And so now I have two sessions logged into the same machine. Sometimes that's really convenient when I want to run a program in one window, but I want to edit some files in another window. And so now I've got two completely independent environments where I can work on the same machine. And so you're not limited to just one machine. You're not limited to just one window. You can open up multiple windows on multiple machines to do a bunch of separate tasks. And so that's, I think, regardless of the SSH tool that you use to connect, whether it's FastX or the Mac terminal or whatever you like, that's a very convenient way to get your work done. Open up a bunch of separate windows. All right, so when we log in, so any questions before we go on? That's kind of it in terms of connecting and so on. I guess one last thing I should say is we have a set of machines here at CHPC that are designed for working on sensitive data, things like protected health information and so on. These machines that we're using today are not those machines, okay? The machines we're using today are going to be machines that are really for non-sensitive, sort of publicly, freely available information. So the only trick when it comes to working on those machines for sensitive information, this is what we call the protected environment. is that you probably need to connect via a virtual private network, or VPN. Connect to the university network that way, and then you'll make a second step to log into those machines. So that's really the only difference about working in our protected environment. All right, so when we log into a system at CHPC, we're connected to what's called the shell, or a shell. And a shell is a program that the Linux provides, and it's an interface between us and the Linux operating system. And so because it's that layer in between, that's why they call it a shell. So the shell provides to us what's called a command line interface, CLI. That's an acronym that you'll see thrown around. And a command line interface is a place where we are typing commands, enter, and the shell responds, okay? And so we're gonna type commands, which are command lines, to the computer. They'll hit the enter key or the return key, and then it will respond back to us. So something that's common in these command line interfaces is that the commands tend to be very short. They're very terse. A few letters is a whole command. The reason for this is typing is slow and cumbersome. It's error prone. And so if you have to type in super long, convoluted commands, you'll never get any work done because it'll take forever. You'll make mistakes in your typing. So you'll discover that when we're working with Linux, we'll be typing a bunch of very short, very terse commands. Also, way back in the day when Linux was invented, the communication channels between us on our client computers and the machines we're working with were extremely slow. At a very slow data transmission rate. And so it actually took a lot of time just to transmit the command to the remote machine. So we made the commands super slow. And you'll come to appreciate, what these short commands can do for you. It saves you a lot of typing. Okay, so when we're working in this command line interface, we're typing commands. We're gonna hit the enter or return key to send that command to the Linux side. The shell will interpret and work on that stuff, and then the results back to you. Not every command is going to show you results. A lot of commands are very quiet. Simply do what you want it to do, it'll show you a prompt again, and it's done. And you wonder, like, did something happen? It's like, well, yes. Typically, that's a good thing, right? They will show you mistakes or something. But if not, they will quietly say, okay, done, continue. They'll just give you a prompt and away you go. So with all of these commands, we have the ability to modify their behavior by giving them arguments, like say the names of files we want to work on, and also options, different ways to modify their behavior. So, comment? Let me see if I can mute. Hey, all you remote people, would you please mute your microphones? Let's see here if I can find that. Let's see. Okay. Okay, I think that was that person. Okay, we're good. Great. You folks online, if you'd please keep your phones or your computers muted, that would be appreciated. Thanks. Okay, so we're typing commands, the command gets executed, then we get back to a prompt. And we can use these flags or options to tell the commands, how to modify their behavior. And so we'll show you lots and lots of examples of those commands today. And you can see many of those commands on this handout, this shell reference. So this is a list of many of the most common commands that we'll be playing with today. And there are some examples of options down here in these last few commands on the page. So we'll get into those in a few minutes. Okay, so some more shell basics before we dive into it. First of all, Linux is case sensitive. So when you're typing commands or typing the names of files, Linux cares whether or not you use capital or lowercase letters, okay? Typically Linux commands are lowercase, but the file names can be uppercase or lowercase or a combination. And it makes a difference. So if you type in a command in all uppercase and the Linux system says command not found, it may be because you typed in all uppercase letters instead of the proper lowercase letters. So we have our choice of two different shell programs when we're working on Linux at CHPC. And those are called bash and tcsh. Most of us in here are probably using bash. Bash tends to be the more common alternative. There are compelling reasons to use TCSH though for certain users. There are certain chemistry packages like Gaussian, for example, that really work best with TCSH. But all things being equal, if you have a choice, I would recommend you work with bash. And here's why. The bash, these command sets that we're working with, all the commands that are presented to us by a shell, essentially comprise a programming language. We have the ability to write scripts and programs with these shell commands. And the bash syntax allows you some more options on how your programs run. And you'll see this in more detail next time when we get into the real differences between bash and TC shell. So if you have a CHPC account, you will be able to figure out which shell you're using. If you don't like the shell that you have, you can ask us to change it for you. And it takes a few minutes to change, and we're happy to do that. Whichever shell you use, I would recommend choose one shell, get really comfortable with it, and really master it. Switching back and forth between the two, although they're generally similar, can be really confusing. Okay, let's see. So right now we can go in and check which shell are you using. And so I'm going to go over to my terminal window here, and I'm going to issue this command, echo. Why did my window die here? Let me terminate that window. Let's see. I'm going to restart my connection. For some reason, it died off. Let me blow that up a little bit so you can see. Okay, here's a command. Echo space $shell. Okay, so this is a command you should be able to run in your window right now. And what I'm asking here, I'm using the shell echo command, and I'm asking it, what's the value in this variable, shell? And it says back to me /bin/bash. So I'm a bash user, okay? So feel free to go give that a try in your own window and see if that works for you. So if I'm using bash and I don't like the fact that I'm using it, I can also start a new shell. I can say tcsh, for example. This is the name of the other shell. And so now when I go into that, I'm now in a TC shell window. Now it doesn't look any different, but in time I will show you, what that looks like to work in these two different shells. Yes? Okay. So you are using a TC shell then? Okay, so that's totally fine. Mm-hmm. Let me take a look. I'm not quite sure I understand the question. Okay, great. So you echoed shell, you've got bin TC shell. So that is your default shell whenever you log onto a CHPC machine. Okay, and that is totally fine. So if over time you discover that you don't like how TC shell works, you can ask us to change it and we'll change it. Okay. So that's great. All right, so that's a bit about the two different shells. When we get into scripting more next time, you'll start to see the differences between the two. And that'll be a time when you decide, hey, I like bash better, or hey, I like TC shell better. And you can make a decision about whether you want to change or not. So here's some other useful things for you to understand about the shell. So as I mentioned before with these command line interfaces, all of our interaction with the computer is through typing, which can be a really cumbersome thing. And so the designers of these shells have created a bunch of little utilities for us to save us from having to type so much. So if you use the up arrow, you can hit the up arrow once or more, and you'll see the previous commands that you have executed. So the shell keeps a history of all the stuff that you've done. And if you want to reuse some of those commands, you can simply hit the up arrow key on your keyboard, and you'll see the previous commands listed there that you have run. Okay, so you can just hit the up arrow, and re-execute that command or edit that command. So let me show you another command here. I'll type the command ls. So this lists the files where I'm located in the computer right now. So I type ls, I hit enter, and it shows me these are the files in my location on the computer right now. So if I want to repeat that command, I can simply hit my up arrow and the ls command appears, right? So I don't have to type it over again. So this is one of the many ways you can save yourself from doing a bunch of extraneous typing. Another thing is the history. So history is a command which you can type and hit enter. So let's do that now. Say history, enter. So this lists a long list of all of the commands that I have typed in the recent past on this machine. And so you can see my history goes up to 504 different commands, okay? So if you're just starting out and you just got your account, you might have a history of just a couple commands or 10 commands or something like that. And over the years, it will build up to many thousands of commands. So with this history list then, you have the availability to replay commands using this exclamation point. And so what I can say is, okay, I can see that command number 493 here is one that I want to replay, okay? So I can hit exclamation point 493, I hit enter, and it replays command number 493, whatever that was in my history. So that's another way to prevent you from having to retype all these commands. Some of these commands can be very long and very cumbersome to type. So you can just hit exclamation point and the number of that command from your history to replay that thing. So another convenient way to save yourself from a bunch of extraneous typing. Yet another thing that the shell provides is called tab completion. So when we're executing commands, we're typically running a command on some file or files that the command will then manipulate and process. And the shell is smart about this. Let me show you another command here. I can use my ls command, and instead of just showing me the files in my current location, I can look at the files in some other folder or directory. So in my account here, I've got these directories or folders, intro Linux 1, saved files, and so on. I can type ls intro Linux 1. I can type the whole thing out. Or if I back up, if I just type the first few letters of a file that I'm interested in, intro, and then I hit the tab key, the shell completes it. The shell does all that extra typing for me just by hitting tab. So when you're working with very large descriptive file names, and large and descriptive file names are a good thing because it tells you what's in these files, you can use the tab to save yourself the hassle of typing all these things out. So remember that exclamation point thing is great for replaying old commands. The up arrow is great for replaying old commands. And the tab completion is great for having to type everything out. So it's in ways like this that the shell tries to make it really convenient for us as users. Okay, questions? Yes?
File names case sensitive also?
Yes, they are. So there are some, the vast majority of Linux systems are case sensitive. There are some alternative machines that have case insensitive file names. And it can be confusing, like if you make those file systems from other machines available on the Linux side, you could access those through your Linux account. But the rules get a little strange as far as file naming goes. The way that, like for example, I typically have some files and directories that differ only by the upper and lower case letters, right? And so on those systems where the file systems are case insensitive, it can be a little dodgy about uniquely specifying files. But on the Linux side, the file names are case sensitive, and it is encouraged to use both upper and lowercase letters to produce readable file names. Yeah, great question. Okay, we can edit previous commands. So we're not stuck with just replaying the exact same command. I can use, for example, my up arrow. Let's see here. So here's a previous command I just ran, ls intro Linux 1. So if I don't want to ls that file, I can ls some other file, like saved files, for example. So simply by over typing on that command, I can edit what I'm going to execute here. So let's say, here's a command that I just ran. Oh, let's say I wanted to modify that a little bit. I want to add an option, a command line option to that command that I ran. So I can use my up arrow, backspace over that, using my left arrow, I should say, to backspace into that command and retype it. So you have the ability to edit commands on the fly as you go here, which is very convenient. Okay, so that's a lot of useful things for making the shell easier to use through tab completion. So let me talk to you a little bit about what we call the directory structure or the file system in Linux. So you're probably familiar with computers that give you a graphical user interface, like a Windows machine or a Macintosh, where you have this idea of a desktop with folders that contain other files, folders contain other folders, and so on. So this idea of a folder came out of a project back in the 70s where they were trying to think of, how can we present computers to people in a way that's familiar to them, like working on a desk with folders of papers and stuff like that. It's called this desktop metaphor. And the idea of a folder really maps onto a thing in the computer called a directory. It's really just a collection of files. And so whether you use the concept of folder or the idea of directory, it's really all the same. So all of the files on this Linux computer are organized into a big folder or directory system. And these, within the Linux environment, the different levels in this directory system are separated by this character, which we call the slash. Okay, this is the character on your keyboard right underneath the question mark. So this is technically a forward slash as opposed to the backslash used in Windows. So this forward slash separates different levels of folders or directories in our file system. And the very top level of this whole structure of directories is simply called slash. This is the root of the file system, or the root directory. All the other files are accessible through this root of the tree. So you can think of this as like a big upside down tree structure that branches out. Starting with the root or the slash file system, it has subfolders, those have subfolders, and so on. And it's all in one big organization system. If you're familiar with, in the Windows system, how you can have separate drives. You might have your A drive and your B drive and your D drive where you keep files and so on. Linux doesn't do it that way. Linux keeps it all under one big roof, okay? So when we log in to a Linux machine for the first time, we're located in what's called our home directory. It's our home folder where all our personal stuff is located. Every person on the system has their own unique home directory. Typically, all the home directories are kind of grouped together in the same place, but we don't share the home directories. Right? We all have our own unique thing. So this home directory is used to let's see. So this is sort of your base directory. This is where you start a session. This is where you keep your personal files and stuff. This is where the files that define how your shell personally is set up for you, which might be a little different from how mine is set up for me, for everyone else's. When we're manipulating files out in the Linux world, there's really two different ways we can address those files. We can either use what's called an absolute path, which is the name of a file beginning with the root of the file system and all the folders in between. And so these are paths. So a path is a way we describe the location of a file out in that file system. And these paths that begin with a slash, that starts with the root, that's called an absolute path. So we're saying this is the path from the very beginning of the file system all the way down to that file. So you could think of this in a sense as your complete mailing address, your name, number, street address, city, state, zip code, country, et cetera, right? That uniquely defines your home on the whole of planet Earth. And every file in the Unix system has a similar address, starting with the slash. A more common way of dealing with, so these long path names, starting with the root, can be kind of cumbersome. And a more convenient, more common way to deal with files in the Linux sense is what's called a relative path. And that's relative to where we're located in the file system ourselves. So if you're working with if you are in your home directory and you're working with files that are in your home directory, you can simply refer to them by their short name without all this preceding slash this, slash that, and so on. And so frequently you'll find yourself dealing with files using these relative paths relative to where you are located in the file system. So it's very common in a Linux sense to position yourself in the Linux file system close to the files that you want to manipulate. It just makes it a whole lot easier and more convenient. So when we start moving around a little bit, you will see what that looks like. Okay, so here's a drawing of this kind of directory structure or file system to give you a sense of what this can look like. And this is a very simplified version of what a Linux file system might look like, but it provides a useful example for us to play with. So under this slash, which is the root of our whole file system, we see a number of separate folders or directories. So etc, dev, home, user, and so on, okay? So these represent folders directly under the root of the file system. Then underneath home, we have a bunch of other folders or directories. And these are the homes of specific users. So Jono, Mako, Corey, these users have their own home directories located under slash home. And then we see that Jono has created additional folders, work, and photos for their photos and their work files and so on. So under your home directory, you are welcome to create lots of files, lots of additional folders, and organize your stuff however you see fit. Okay, so at CHPC, so every computer center organizes their file system a little differently. At CHPC, you'll discover that your home is located in a place called /uufs/chpc.utah.edu/common/home. So let's go back into our shell windows, and I will show you a few commands here to discover how to move around, how to look around, and what directories are called. So the first one I'm going to show you, and this is listed about halfway down this list of basic commands here on this handout, is called pwd. This is print working directory. This is essentially asking, where am I located in this whole huge Linux file system? So give that a try, pwd. And so this lists out my current working directory as /uufs/chpc.utah.edu/common/home followed by my unit. Okay, so that's telling me that I'm in my home directory, and and that's kind of what it is. So another command that's useful is cd. That's change directory. This allows me to move myself around within the file system. So I'm going to say cd/uufs/chpc, and let me show you again this great tab completion stuff. chpc tab, and it completes the rest of that string out. Common home, and now I hit enter. Okay, so I changed directory with cd. I gave it the name of the directory I want to go to. I hit enter, and the shell just comes back with a prompt. So, how can I tell that it did anything? Well, it didn't complain, right? It didn't give me an error message or anything like that. So I'm going to assume that it worked. So now I'm going to type pwd again. So now I'm in uufs/chpc.utah.edu common home. Okay, so I successfully moved from my home directory, which is this U0424 number, into common home. Okay, so I've moved to a different place. So now a useful command is ls. So this lists out the files that are located in the current directory, ls. And when I do that, I can see a whole huge number of different directories are located here. Lots of files and directories. So these belong to other users. These belong to research groups on campus, research projects on campus, and so on. Okay? So at any time, so let's go back to that cd command real quick. At any time, if I want to go back to my home directory, I can just type cd enter. So cd without any arguments, without any extra parameters, simply takes me home. So by default, it just goes back to your home. So it's very convenient. Okay, so I'm going to use my up arrow. So I'm going to CD back into this UUFS CHPC common home. Okay, I'm going to type PWD. It shows me where I was, print working directory. Okay, CD, enter. That takes me back home. All right, it's as simple as that. So what if I give CD some nonsensical directory to go to? CD/foo/bar/etc. Okay, it says bash cd foobar, etc. No such file or directory. So this is the shell telling me you did something wrong. You screwed up. You typed the name of a directory that doesn't exist, and I can't take you there. Okay, so this is typical of a Linux kind of interaction. If it works, it's very quiet. It doesn't say anything back. If it doesn't work, then it gives you an error, and it tries to give you a little bit of information about what you did wrong. Okay, so let's do some more moving around here. I'm going to CD back to my home. I'm going to type PWD, kind of confirm that's where I am. So now I'm going to type CD space ... So ... is a relative path name. Okay, it's not a full absolute path because it doesn't start with a slash. It doesn't start with the root file system. ... is shorthand for give me the parent directory, the directory one level up from where I am. So CD ... So now I PWD and I'm in UUFS CHPC common home. So I'm one level up, one level closer to the root from where I was in my home directory. So let's do that again. I'm going to use, yes?
If you want to go 2 levels up, you do ...
You absolutely can do that. So you can do CD ... /... So that takes me up 2 levels. So if I do that, now I'm in /UUFS CHPC. So I had been in home, I skipped through common and went up 2 levels. You can do that as many times, you know, ... /... You can do it many, many times. Yes, absolutely. Okay.
If you run out of stories,
Mm-hmm.
it takes you home.
No, let's go try that. So CD/, let's go to the root of the file system. So now we're at the very top level. We can't go any higher, right? So if I say CD ... I'm still at the top. I'm still at the root file system. And so when you get to the top and you try to go higher, you're just stuck there at the top. Yep. Yeah, so the Linux file system is kind of bounded or self-contained in that way, right? You can't really get lost. You're always in a directory somewhere. And if ever you just, if you find yourself someplace and you need to get back to directories you're familiar with, you can simply CD, enter, and you're back home. So it's really simple to move around that way. Okay, so that's CD and paths and moving around and so on. Let me show you one more thing. I'm in my home directory. If I CD ... so now I'm in the UUFS CHPC common home directory, and I want to go to some other directory here. I can say CD and then give it that name. So it might be my directory. So that takes me back to my home directory. I might go to CD space, let's see, what's another place I can go? Let's see, I don't own any of these files. Okay, so what's your unit? You. 602. Okay. Let's try. Okay, it let me in. Okay, so now I'm in your home, right? I'm a guest in your home. Thank you very much, right? And so this is a useful thing to know how to do when you want to exchange files with, you know, a collaborator, a colleague, or something like that. A colleague can say, hey, I left some files in my home directory for you. You can go and copy those files and put them back, you know, take a copy of them and then go work on them and manipulate them. And we'll actually do this in a few minutes here. So this is a great example. If someone else knows your login on the machine, then they can easily go to your home directory to find some files that you've left for them. So next time we'll talk about file permissions and how you can prevent other people from seeing your stuff or from damaging your stuff or removing it or whatever. So you've got complete control over who has access to the files in your directory. And so I'll teach you the commands to open those files up for people to see or to lock it down if you don't. Okay?
So knowing your login is just
That's right. Here at CHPC, we use our UIDs for logins. Yep. Yep. And so typically on academic computing centers, things are kind of open. There's generally sort of a sense of trust, that you trust your colleagues to mess with your files and so on. It's actually a really serious offense to go and mess with somebody else's stuff without their permission to do so. I'm sorry? That's right. In our protected environment, it's a completely different environment. Everything is locked down to the maximum extent possible because there is a presumption that the files there are sensitive and that only select individuals should be able to see anything. So you really can't go and look at files that don't belong to you. In this general environment, though, it's a more open, kind of trusting environment. But people, I think I'm one where I don't really want to take the chance that someone will either maliciously or accidentally mess with my files. I tend to keep my stuff kind of locked down, and I will show you how to do that, and it's up to you to treat your files, how you feel comfortable. Okay, so let me show you another way to address a person's home directory. So I'm going to CD back to my home directory. So I could use my knowledge of where the home directories are located to get to her home directory. But I know her login, and so I can simply do this, tilde, and then use her login. So tilde followed by a login is Linux shorthand for the home of this person. Okay, so I'm going cd space tilde and that login, and now I type pwd, and I'm in her home folder. So this is a really great shorthand. If someone says, hey, go grab the files out of my home directory, and you can say tilde and their login, and that gets you the name of their home directory. Okay. So the tilde character on my keyboard is up above the tab key. Question?
So is that something specific to the directory structure of CHPC?
No, this is a Linux thing.
So regardless of what you call home, so that you there.
Exactly. Yep, exactly. So this is universal to Linux systems. Yeah, Unix in general, under the hood on a Mac, it's running a operating system very much like Linux. And every Unix and Linux I've ever worked with has used that tilde shorthand to mean the home of this person. And so whether that site organizes files the way we do here at CHPC under /UUFS, yada, 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 or they do it some other way. Exactly right. Yeah. So it's a really convenient thing. A lot of these things, as you gain experience with different Linux systems, you'll come to see what is Linux versus what is the University of Utah's interpretation of how to set this up, right? So, okay. Any other questions about CDing, home directories, tilde, ... Okay, great.
Question.
Yes.
So when we were typing her login,
Yes.
so she already gave you 602. What did you type to finish again?
I hit the tab key. So that tab key, that tab completion, works when it can uniquely identify a file that begins with the letters that I typed. And so at any time, if you're not sure, you quite remember the file name, you can hit the tab. If you typed part of the command name and you're forgetting the rest of the command, hit the tab key. And more often than not, the computer can figure out what it is you're trying to type and will complete it for you. Yeah, great question. Okay, so I'm going to go back to my home directory. Let's go back to our slides here. Yeah, so you can, so back to your point, Ali, this shows, in this interpretation of a Linux file system, the user's home directories are under /home. Here at CHPC, we bury them several layers further down. But whether you're on this diagram here or you're in our actual file system, tilde username takes you to their home, wherever that might be. A directory structure like this?
Yeah.
Yeah. Yeah, Wim mentioned Ubuntu. So here at CHPC, we're using a brand of Linux that's called CentOS. But there must be, gosh, there must be close to a dozen different flavors of Linux out there. Red Hat, Ubuntu, Debian, SUSE. There are a ton of different ones. And the skills that you're learning here will apply to all of those. Those are, there's enough shared, enough common to all of those that what you're learning today will apply to any of those. Okay, moving right along. So logins and prompts. So when you first log into the machine, you'll see the prompt. So here's the prompt that I get when I log onto this machine. If you're user number 33, it might look like this. Here's some more useful commands. To see your username, who did you log in as? You can type, who am I? So it can be confusing sometimes if you have a bunch of different accounts on different systems and you wonder like, wait a second, which login did I use to get in here? I can type, who am I? And it says, I am, exactly, I'm U0424091. So PWD, we already talked about. Another cool one is who, that shows me who's logged into the machine right now. So we can see we've got user 34 and U10777781, and we've got me and user 02 and so on. This shows when this person last logged in. It shows from where did they log in and so on, okay? So that's the who command for you. Shortcuts, so we talked about tilde. I'm sorry? I don't think all of these are on here. This covers most of them, but there are many things here that may be missing here. So we talked about tilde, so that's the shortcut to your home directory. So if you just use tilde by itself, that means your home. If you use tilde login, like tilde user 33, that means the home directory of user 33 or whoever's login that is. So tilde username, right? That's the home of that username. And then another thing I mentioned here is $home. So this is another way of representing your home. This is a thing called an environment variable. We'll get more to environment variables in a little bit. That's another topic that I'll bring up in a few minutes. Okay, so here's our first exercise. So get yourself logged in, figure out what your shell is. You can use that echo $shell command. Figure out what is your username. So you can use that who am I command. And what is the path of your current directory. So give that a try, go through in your shell, in your login, and try those 4 things and see if you can figure it out. Raise your hand if you get stuck. It should just take a few minutes.
Very different question. Maybe you're different things.
Mm-hmm.
I was trying to collaborate with you, said, I'm going to my own file and so I tried to pseudo find it.
Mm-hmm.
But then I just said, pseudo is not
Right.
in this, like this will be recorded. And I was like, but
So-
you didn't give me the path.
Right.
I wasn't sure.
So you probably don't need sudo for that. So sudo is a Linux command to essentially take on the identity of another person, right? And so the way you typically use it is, and so only specific individuals are allowed to sudo on a computer. And so the system administrators tend to lock the sudo command down to specific individuals. So if you're the super user, if you're the system administrator on the computer, you kind of have the ability to do anything, whatever you want, right? Sudo is a tool that they can use, that sysadmins can use to grant individual users the rights of specific other people or capabilities on the machine. So I'm not a system administrator, but I've given the right to install software on these machines. We have a shared account that we use for that. So I can sudo to that shared account and temporarily become that other person while I do this work with those elevated privileges. Okay, so let's look at this after class, but your colleague Your colleague probably gave you instructions on how to find specific files, but you may not need sudo access to do that. Yeah. Right.
A lot of the things that I've been shown how to do is one specific way.
Yes.
And that's similar. So there's probably another way.
Yeah. Well, let's look at it. We'll figure it out.
Okay.
Yeah. So I'm going to tell you about a command called find, which is an incredibly powerful tool for locating stuff on the machine. And that's kind of a typical first step for a project of, oh yeah, go into the group, the shared group space that our lab has and find this file. It's called something or other like, you know, and it's up to you to kind of sleuth around and figure out what it is you're looking for. Yeah, this is a very, very common thing. Okay, did anyone have any challenges with any of the exercise here? Any questions about this?
The last one, what is the fact? Was it the way you do tilde user 01?
So the easiest way for this last one is simply PWD. So print working directory. So wherever you are, that prints out where you are located in the file system right now. And of course, you can change your location with that CD command. Okay, so basic directory commands. So when you're in a, well, every time you're logged into a Linux system, you're in a directory somewhere, right? Wherever you are, there are some commands you can use that'll help you look around. So ls is one that we looked at a little bit. This lists the contents of a directory. And ls by itself, let's see, I'm going to cd to my home directory. I'm going to cd ... So now I'm up one level in the home directory. And I type ls. And it simply lists all the files or directories that are located in this current directory where I am. Okay? So ls by itself just shows you the names of those files. There are lots and lots of options we can use to get more information about those files. So the most common one that I use is ls space -l. So that space is really important. When we're running commands in Linux that have arguments or options, those arguments and options are always separated by each other by one or more spaces. So when the shell is looking at the command that I typed, it's looking at all the characters that come in on that line, breaking it up by spaces, and then saying, okay, what's the first chunk, the first space delimited stuff on that line? That's the command that Brett is trying to execute. The subsequent pieces that are separated by spaces, those are going to be the arguments or the options that he's giving me to execute. So ls space -l. I can also say ls space -l. Same thing, okay? So I hit the enter key and I get a whole bunch of stuff out here, page after page after page. So you'll notice this right-hand column, these are the names of the files that are in this directory. And all this stuff over here, these are additional pieces of information about each of those files, one per line. So this is a typical ls -l output. This is a long listing of all the files that are there. So we'll get into all the details about what these different things mean in time. A few things that are handy right now is to see this first letter on the line is a D. That stands for directory. That's telling me this thing, andereg-group1, is a directory. So I can cd to it, for example, right? You can cd to a directory. You can't cd to anything that's not a directory. Let's see, what else? This has a date associated with it, January 24th at 12:20. So that's going to be the time that someone last made a modification to that directory or that file. So we can see that there's a directory here owned by the astronomy people. There's a directory here from the biomedical informatics people. There's stuff from all these different laboratories, okay? And you can see the dates associated with each of these. Okay, so that's ls-l. Oh, so we can, if we want to know more about the ls command, a fairly common, what would you call it? It's like a fairly common practice or protocol is to give the option --help. Lots and lots of commands have a --help option. So if I hit ls space --help, it shows me page after page of information about what the ls command can do. So it's sort of like a little online help document about this command. So you can try that with a lot of different commands and see if that help option is available. A more surefire way to get help about these commands is the online manuals. So Linux comes with its own built-in manuals for you to read, and you get to them through a command called man, M-A-N, short for manual. So you can type man space anything, man space ls, and this shows me the online manual for the ls command. So when I do that, I can see the first page of the manual comes up, and I'm looking at this help documentation using a particular piece of software that's called less. Less is a program that shows me information a page at a time. And it's used by the manual system. It's used by a bunch of other things as well, and you can use it yourself. But it works like this. Right now, it says at the bottom, we're looking at the manual page for the ls command. And we can type press H for help or Q to quit. Meaning if we want to get out of this manual page, I can simply type Q and I'm back out to the shell. So it's easy to escape. So let's go back in there, man ls. So the manual pages are fantastic because all of the stuff about Linux is documented in here. You just kind of have to know what to look for. But there's no harm in typing man space whatever and to see if man will have a page, or if the manuals have a page to describe this thing. But once you get in, you can simply type Q to get out. So I can hit the space bar to go down a page at a time. And you'll see that for this particular command, there's all these different options listed over here on the left. There's the -G option, the -H option, and so on. There's lots and lots of different options for the ls command to change the format of the output that ls gives you, okay? So you can go, so -T, for example, let's say you want to find the files that were modified most recently. You can do an ls-lt, and it will give you a long listing in order by their modification time with the newest files first. So you can say, oh, show me the files that were most recently modified in this directory, for example. That's a really convenient thing to do. Okay, so that's the manual system for you. Let's see. So we've talked about ls. We've talked about manual pages on ls. Okay, now let's try making our own folders, our own directories. We're going to use a command called makedir, M-K-D-I-R. So I'm going to go back into my shell, back to my home directory. So I'll check with pwd, and I'm going to say makedir test directory. Okay, I hit return, and I get nothing back. So that's a good sign, right? That's typical Linux for you. It's not telling me stuff when everything worked. So now when I type ls again, I can see right here, there is a thing called test directory. So if I type ls space -l, I can see that test directory exists. It's owned by me, so there's my name associated with it. So what directory are you in?
User 01.
You're in user 01. Oh, that's weird. That's very strange. Is that your home directory?
I'm the guest user.
You're the guest user? Yeah. That's very strange, because in your home directory. Ah, okay. So type CD and hit enter. So that'll take you home. Ah, okay, good. That's good. So things are working as they should. Okay, so take a look at this ls-l output with me. So I've got a couple directories here, and now I have this brand new thing called test directory. It was last created at 2:11 on January the 28th, which is just a couple minutes ago, right? So that makes sense. That's working nicely. So now test directory, I can see over here in the first column, there's a D, so that means it's a directory. So I should be able to cd space test directory. And now there I am. So I create a directory, I can cd to it. So I've changed to it. It's now my current working directory. If I now type ls and hit enter, I see nothing. Okay, this is a brand new empty directory that contains no other files. Question.
So when I was trying to create a folder like notes,
Hmm.
instead of creating it in CHPC, it created it. I don't know, I have my user ID and Dr. Rick's name.
Hmm.
I wonder why.
I don't know. Let's take a look.
Sorry. Seems strange to it because
Yeah, CD. Okay.
So, that's a great question. Let's look at that right now. I'll do the same thing. Okay, so CD tilde. Can you tell me your unit, please?
U602-7354.
Okay, so now I'm in your home directory.
There should be notes.
Okay, and there is. Okay, and it was created just now. It was created at 2:11. Okay, let me show you some other things that LS is showing us here. So this column here, this is the owner of that directory, so that's you. This right here, so you work with Dr. Wick. So you belong to the Wick group. Okay, so all of us within the Linux environment, we have our own unique logins. We also belong to user groups. So typically at the university, the group to which you belong is the name of your boss, the name of your PI, or something like that. Okay, so when we look around at the rest of the information about this notes directory you created, this set of letters over here on the left, these indicate the permissions associated with that particular directory. And I guess we have to cover this at some point. Why don't we cover this now? So the permissions that we see here are presented in 3 sets of 3 letters. So you'll see an RWX, followed by an R-X, followed by an R-X. So these R's and X's and W's, these correspond to, can you read it? Can you write it or modify it? And can you execute it like a program? Okay, so there are 3 separate sets. So the first set of 3, RWX, correspond to the user, the owner who owns this file. And so that's you. So you have the ability to read and you can write, so you can modify that notes directory, and you can execute programs in it. Okay, so the second set of letters, R-X, those correspond to other people within Dr. Wick's group. So people within your group, they can read it, but they can't write it. So they can't go in there and they can't make changes to that directory or the files in it. The third set, RWX, this corresponds to everyone else in the universe that's not in Dr. Wick's group. That's me, that's Wim, that's everybody else, okay? So if I go into your notes directory, okay, I can do an LS, I can look around, I can read. What happens if I try to make dir another directory, okay? So I don't have write permission in this directory. So when I hit enter, it says permission denied, right? I don't have permission to change these files. I can't create directories. I can't do anything except look around. And so these default permissions are set in a way that people can look at your files, but they can't change them. They can't mess with them. And so that's a pretty reasonable default setup for permissions on a system like this. People can look at stuff, but they can't change them. No, this is perfect. You're doing great. Okay, so when I look at my own home directory and I type ls-l, I can see I've got a bunch of directories here. I can see I have the same types of permissions, but because I own these directories, these permissions apply to me. So I can write these directories, but no one else can, right? Because you aren't me. So you can see here's my login name. So this is the owner of these files. That's me. This is my group. So I work at CHPC. So I'm in the CHPC group. And you can see that these directories were created on January 23rd or 28th or whatever. Okay. So that's what LS can do. And that gives you a glimpse into what the file permission system in Linux can do. Okay. All right. So any questions about that before we go along? Yes.
I'm sorry,
No.
I'm just missing something. What is the initial D for?
The D tells you the type of file. In this case, it's a directory.
Okay, so I was just looking through.
Mhm. Yeah. So
So there's some that there's no slash.
Mhm. Right. So those are so-called regular files. They could be data files or source code files or documents or things like that. So if you have some PDF files lying around or something like that, those will just have a dash. So a directory, so there are a number of special kinds of files and they have a single letter abbreviation like D for directory. Or you might have something like, I'm trying to think of some other special kinds of files out there. Like there are files in the Linux system that correspond to the hardware. So those things have different special letters. But most files, just regular files that contain, text and data and stuff like that, they'll just have a dash in that first position. An S for a link, for a symbolic link, yeah. Yeah. Okay, so let's go back. Let's see. We've already talked about CD, CD ... and so on. We've looked at make dir. Let's try remove dir now. Okay, so here I am in my home directory. So I made this directory called test directory. So now let's try to get rid of it. rmdir test directory. So the remove dir or rmdir command removes directories, whereas make dir makes directories, okay? So I hit enter. I don't get anything back, so it must have worked. So let's do an ls, and you can see it's gone, okay? So you can blow directories away just as easily as that. Okay, yes? Let's see. Oh, that's a great question. Let's make dir test directory again. Okay, so what I did was, okay, so here we are back with my test directory. I typed rmdir, I said type test, and then I hit the tab for tab completion. And tab completion automatically puts that slash on the end, just to say, hey, this thing is a directory. But I really don't need that slash on there to remove it. Yeah, so if I rmdir test directory, it goes away. Okay, let's try something else.
So if you put a gap there, it doesn't.
That's right. That's right. The shell is a little bit lenient when it comes to dealing with directory names, whether you put a trailing slash on the end of it or not. Yeah, yeah, that's a little strange in a way. So let me do something here. I have a directory here called tmp for temporary files. And if we do an ls space tmp, I can see I've got a whole mess of files in there from other projects. Why don't we remove that stuff? So I'm going to do a rmdir tmp. And I got an error. It says directory not empty. So Linux is complaining to me that I'm trying to remove a directory with rmdir that still has stuff in it, right? And so this is a nice thing about rmdir. If I want to get rid of tmp, I need to go into tmp and then explicitly remove the files that are in there first before I can remove it with rmdir. So I'll show you in a little while. So this is like a nice safe way to clear out directories, right? You can't mistakenly go and rmdir a directory that has a bunch of precious stuff in it. The system won't let you do that. But there are commands that, even if you put the slash at the end, it won't do it. But there are commands that do let you do this, and we'll get to those in a bit. There are commands that with a keystroke, you can blow away all of your files. And so I'll try to show you how not to do that, because Linux will certainly let you go and do that if you choose to do that. Okay, so we can make dir, we can remove dir. Let's see what's next. Okay, so we talked about the ls flags a little bit. I showed you in the manual page what these can do. Here's a summary on some of those flags. There's the -l, that's the long listing that shows you the permissions, the owner, the group ownership, the last modified time, and all that stuff. There's also a really useful option called -a. That's a really important one to know. Let's cd back to my home directory. I'm going to clear my screen here with the clear command and type ls. So you can see I've got a few different things here. I'll do an ls -l. You can see these are all directories. But there's more here than meets the eye. ls is choosing not to show us a bunch of files that are here that are so-called hidden files. And if I type ls space -a and hit enter, I see all these files here, and they all begin with a period, with a dot. So I've got this .gstreamer.010, .fltk, .fdt, and so on. I must have 100 different files here that all start with a dot. This is something that Linux does sort of as a convenience to hide a bunch of configuration files and things like that that we typically don't deal with on a day-to-day basis, but they're important in terms of creating and setting up our environment on the computer where we're logged in. So there are a few files here that are especially useful. I'm going to use this less command. This is the command that we use, that's used by the manual pages, the online help system. And there's a file that I have in my directory called .bash_profile. So this is a file that gets executed. It's a bunch of shell commands. It gets executed every time I log into one of the CHPC machines. And it sets up a bunch of stuff in my environment, like what kind of prompt do I get? It sets things like environment variables, my path, which I'll get to in a minute. But when I do this, it shows me, here's a bunch of system shell commands that are creating my environment for me whenever I log in. So each of you have similar files similar to this. You may have a bash profile if you're a bash user. You might have a .tcsh file if you're a TC shell user. And I would say for now, it's good to know that these files exist. And next time we'll get more into kind of what these files are doing for us and how they work. But, yes?
So your files have different colors.
Mm-hmm. There are. So the blue things are all directories. The green things are executable programs. So I can simply execute that like it was a command name. The black ones are simply data files or scripts that are not literally executable. When we get more into scripting next time, you'll see when we change the permissions on these files in order to execute things, that will change the colors for them in the ls command. Yeah, so ls is useful that way in color coding different file attributes that way. Yeah, great question. So that ls-a option is a great way to display those hidden files that otherwise the shell just hides from us. Yes?
So the way it's lined by column,
Yes.
this column has nothing to do with that. It's just trying to put as much information in the screen.
Exactly. And it just does it alphabetically in a series of columns. So ls by itself is just going to show me the file name, so it packs as much in as it can. Whereas ls-l shows it all, let's see, ls-l shows them one file per line stacked up. Great question. Okay. So that's ls-a and what those hidden files are. There's lots of other ls flags. -r reverses the sort order. So by default, it shows things to us alphabetically. So if you do an ls -r, they come out in reverse alphabetical order, for example. This -t sorts the files based on their time. So you can ls-rt or -tr to do it in reverse time order, okay? So you can mix and match these different flags in different ways. Okay, let's see, files and file names. So we know that directories can contain files and other directories. In Linux, files can have names like homework.pdf. It can have an extension on that file name. So the way file extensions work in Linux is those files are useful for telling you what kind of contents they might have. Like if you have a file called homework.pdf, that's probably a PDF file, but it isn't necessarily a PDF file. It could be anything. So those file names are really just a convention to help you understand what's probably in that file, but it may not necessarily be the case. There are other operating systems like DOS, like Windows, for example, where the file name extension is really tied to what the file is. That's not the case in Linux. You can call any file whatever you want, okay? You can call a PDF something .txt, even though it's not a text file. That's perfectly legal to do. So there is a command in Linux called file, which will tell you what is the contents of a particular kind of file. So let's go try that. So here I am in my home directory. I'm going to say file space intro Linux 1. And it tells me that is a directory, okay? This is a great command if you're exploring around in some directory, you don't know what the files are, and you want to understand what these things are. It is absolutely harmless to go and ask, what kind of file is this thing, using the file command. Okay, so be careful with file names to make your life easier in Linux. So here are some guidelines. There are some special characters that you can use, but it makes your life difficult if you do that. So for example, you can put spaces in file names. It's a hassle in Linux if you do so, because our Linux commands, the Linux shell uses spaces to identify different parts of a command. And so if your file names contain spaces, that will confuse the shell. You can do it, but we recommend you don't do it. So tabs. Tabs are another thing you should avoid putting in file names. Again, you can do it, but it makes it really confusing when you're trying to specify the name of a file in the shell. Slashes, backslashes, $signs, or leading dashes. These are all things that are actually legal to do in Linux file names, but it confuses the heck out of the shell when you try to access those files. Because those things like slash, the Linux will think, oh, that's the beginning of a directory name or of an absolute path name, right? $sign, Linux will think that is an environment variable as opposed to a file name. So although you can do it, we recommend against it. Okay, and we already know that files that begin with a dot are hidden files. You can absolutely do it, but ls won't show them to you unless you use that -a option.
Maybe one comment. So for instance, when you have a file for Windows, in Windows you can have spaces. There are two ways to do that. So either what I do is I put quotes in the start and at the end, and then it knows it's a string. Or you can use the backslash for every blank, every space, but that can become cumbersome. So quotes is probably the easiest one.
Quotes is a great trick. I've never tried that. That's a really good idea. Yeah, if you tap, let's say you have a bunch of files on your Windows machine, and they have spaces in the names, you transfer those to your CHPC account. Then if you need to manipulate those on the CHPC side in the shell, just put quotes around those file names. That's a great suggestion. That's a great suggestion. Okay, so login scripts. So we talked about this just a little bit. You have a bunch of hidden files in your home directory. So for example, .bashrc, .custom.sh, .tcshrc, and so on. And ls-a will show these to you. So depending on which shell you use, whether you're a bash person or a TC shell person, different combinations of these files get used to set up your environment. So all of these files are important for creating your environment at CHPC. Let's talk about what that environment is a little bit. There is a command called env that shows what your environment is. So let's go back to our shells here and let's type env. So when I type env, all this stuff comes up on the screen. And my environment consists of a bunch of names and associated values here. So the first thing in my environment is this thing called manpath, $manpath. And manpath is set to the name of a directory where the manual files are located. So when I type man-ls or man-cd, this is the directory where the man program goes to look for those files. There's a whole bunch of other useful things here. So there's an environment variable called hostname, all in caps. And this lists linuxclass.chpc.utah.edu. That's the host name or the name of the machine where we're logged in right now. There's an environment variable called shell. And in my case, it's set to /bin/bash. So that tells me what shell program am I running in my session right now. There's a whole bunch of other things here. There's this this crazy thing called ls colors. This is some sort of a secret code which tells the ls command how to color code the files in the display that it uses. So all of these different variables are used by the shell or other programs to kind of set parameters for how different programs are going to run. We can look at all of these together with this env command. And so that just prints out our whole environment. We can also echo particular variables. So we can say echo space $ hostname. Okay, so that's one of the variables within my environment. And it says Linux class.chpc.utah.edu. So this $ syntax, that $ is a signal to the shell that says, we're trying to look at the value of a variable, of an environment variable here. So that's what that $ is doing for us. Okay, there is a really important environment variable called path. Echo, so let's echo $ path. Yes? I'm sorry, if I was...
If programming like this in Europe, would it be euro sign or
it would still be a $sign. How do you get a euro sign on a keyboard anyway? I don't know either.
This, you can do it, but you have to know the UTF.
Yeah.
UTF-8 thing.
Mm-hmm. We were helping a student last semester, this engineer from Italy, and she has an Italian keyboard. And like all the special characters are completely different. It was a nightmare. So they use...
Azerty is only for French. I know it's,
yeah, it's...
I'm always upset when I have to go home.
Okay, so I'm going to echo $ path here. Let's go look at my path variable. What path is a list of directories where Linux will go and look for commands when I type their name. So when I type a command like man, for example, the Linux system isn't looking in every single directory on the whole machine. It's just looking in a specific set of directories for a program called man for it to execute. And so when we look at my particular path, so my path starts with a directory underneath my home called bin. That's where I keep kind of my personal programs. Let's see, we also have, we have a directory called user lib64qt. We have a directory called uufs sysbin. You know, so there's like half a dozen, maybe 10 specific directories where Linux is looking for specific programs. So if I type some command that's nonsensical, so if I type foo and hit enter, bash says command not found. So that means it wasn't able to find the program that I told it to go and look for. So that means there's no program called foo within my path, within the directories on my path. So typically when you're trying to execute a program or a command and the shell isn't finding it, it's going to say command not found, meaning, you know, the name of the program you type might be legitimate, but it's just not in the directories on your path. So I will show you in time how to modify your path as you install your own programs and write your own programs on Linux. You will have to change your path to include those new pieces of software that you've put in there. Okay, so that is kind of what your environment looks like and how you can look at it. When we get into scripting more next time, I'll show you how you can modify those things. Okay, so let's see. There are a bunch of file commands that let you do all kinds of file manipulation. Before we go into these commands, I want you all to go get some files that you can work with, and I'm going to show you how to get those. We're going to use a command called copy, and you're going to copy some files from my home directory into your home directory. Okay, so type along with me when we do this. Type cd to go to your home directory. Okay, and now I'd like you to execute this command. cp space, and I'll explain what all this means in a second, -r space tilde U0424091/intro, and then hit the tab. So the shell will complete the intro to Linux. Then space, and now type dot. So before you hit enter, I want to explain what this whole thing means. We're going to use the copy command, CP. So copy is what you use every time you want to make a copy of some other file. The next option is -R. So copy by itself will copy a single file and copy it some other place. But we don't want just a single file. We want a whole directory of files. And so that's what -R will do for us. It'll copy a whole directory of files. The -R actually stands for recursive. Yes?
Wow. I wasn't getting to it because I didn't have to capitalize.
Ah, right. Yeah. And you?
If you already have a deck which has a meaning,
Mm-hmm.
what is override the deck?
That's a great question. So if you already have that directory, intro Linux 1, the shell will complain. Go ahead and try and see what it does. It should complain and say that already exists. Oh, you don't have it? Okay, sure. So yeah, so I'll get into that more in a little bit. It can be confusing with copy because copy is a very flexible command and you can use it in a bunch of different ways. And so you have to understand how the shell is going to interpret your command. I'll show you some really interesting and confusing things that can happen with copy. If a file exists with that name, it would overwrite it. It won't ask. If there's a directory by that name, it might put it in that directory. Pardon me. So it can be confusing.
It says,
Intro Linux 1 space dot. Okay, so we know what the tilde means, right? Tilde U0424. That's copying it out of my home. And there's a directory there called intro Linux 1. And so when I type this, I just typed intro and then I hit tab. So the shell would complete that command for me. So I didn't have to type all the letters. You can type them all if you love to type. Space dot. So dot is shorthand for here, for right where we are right now. Okay, so our current work, our present working directory. Okay, so go ahead and hit return and see what happens. Nothing. Okay, that's good. Now type ls, and you should have an intro Linux 1 directory in your home directory now. Okay, is everyone with me?
Just to clarify with the recursive, if you're not copying a directory, but you're copying just a single file, is it redundant or necessary?
I think the shell would ignore it at that point. It is necessary for directories. It's not necessary for regular files. Yeah. Yeah.
You have to have also the permissions, you know?
That's right.
Because otherwise you can make any conflict.
That's a very good point. Yeah. So in order to be able to do this, you all need to be able to read my directory. You need read permission on my files. So if somebody says to you, hey, go copy those files out of my directory, and you do this sort of thing, and it says permission denied, that means they haven't granted you permission. You don't have that R permission thing set in order to read their files. Yeah, okay.
So the R is recursive?
The R means recursive. So recursive in computer science speak means the command will repeat itself for the top level directory and all of the subfiles and subdirectories down below. So this intro Linux 1 directory, when I look in there, it doesn't contain any other directories. But if it did, that cp-r would have copied the top level directory and all of the subdirectories on down the line. Yes. Exactly. So, you know, when you're copying stuff, you're trying to read. And so you need read permission to make a copy of those files. If you're trying to do something else, though, where you're trying to change those files, what matters is that W permission, because you're trying to write, right? You're trying to change. Mm-hmm. Oh, that. So Yeah, so the -R option can mean different things to different commands. So like for an ls, it means change the order. In a CP, it means do this thing recursively. So it's not an order thing so much as a depth of execution thing.
Then you can use the man page and then CP, you will see minus small r and minus capital R.
That's a great point. Yeah, so here I pulled up the manual page on the CP command. This is a really useful thing. Like I've been using Linux and Unix, I hate to admit for how long, literally for decades, and I still look at the manual pages all the time to remind myself, like, what does that option do for that command? Oh yeah, go look at the man page and you'll see what it does. You know, over time you'll find yourself remembering specific options on specific commands that you use all the time. ls-l, use all the time. But, you know, I don't always use some obscure option. I've never used the CP-B option in my life, right? So I wouldn't remember what that does if you asked me. Yeah, exactly. So here we are in the CP page. I'm going to go down this page. Let's see. Or -- recursive. Any of those things copy directories recursively, right? So it'll go down into the different levels of the directory. Okay, so here I am in my intro Linux 1 directory. And let's start going through. And if I do an ls-l, I see I've got a bunch of files here that I own. So you should have a very similar thing in your directory. You should have a bunch of files that you now own. And let's start using these file commands to manipulate these different files in this directory, okay? So let's start with the command called cat. So cat is a program. It's short for catenate. And what it simply does is takes the contents of a file and sends it out. So by default, it's going to send it out to your terminal window. All right, so I'm going to go over here into my directory here. I'm just going to choose one of these files at random. There's one here called full.c. I'm going to cat space full.c. And okay, I can see it coming out on my screen. It looks like a bunch of C language source code. Okay, if I use the file command on full.c, it says, ah, yeah, this is C source code. And so that's kind of consistent with its file name. It's a convention that C programmers use when they're writing a program in the C language. They name their files something.c. And so this is consistent with that. Yes?
So when you use concatenate, what part of the .c file is the end?
The whole thing.
And can you scroll up?
You can't. It's a one-shot deal. If I want to scroll through, so it shows it all to me. It like scrolls off the top. So I'm using my mouse here to scroll back in my window. Here I can see where I executed the cat full.c command. And then here's the file coming out. And there's more and more until finally I just get back to my Linux prompt here. So the whole file is coming out. It might be 10 lines. It might be tens of gigabytes, right? So something I can do then is use ls-l on full.c. And I can see, so one of these columns here, this one right here, this is the size of the file in characters. So this file is only 1,596 characters. So if I cat this file, you know, it's a little bit of data, but it's not a big deal. But I could use the cat command. I could go find a really huge file and cat that file. And it will be coming onto my screen for a long, long time. Because all that data is getting sent out to the output of cat, which at this moment is my terminal. It shows you the contents of a file. Yep. So we'll get into this a little bit more with our scripting, but every time you run a command in Linux, you give it some input like a file name, and by default, its output is going to come to your terminal. And so cat is one of those commands. We're saying, take whatever file I give you, open it up, and send all the output in that file, all the contents of that file to your output. And so in that case, that's sending it to my terminal window.
So if it's a Word document, you can read the Word document.
That's right. You know, if you cat a Word document, you'll just see a bunch of gobbledygook, you know, a bunch of nonsense, because it won't be encoded in a way that we can read without using Microsoft Word to look at it. Yep, that's a great question. And that's a place where you can use the file command. You can use file space and the file name to ask, is this a file that I can even read, right? Before you can go and cat the file. You had a question?
Yeah, I think we need to but what was that please command you typed in?
Let's see. I used ls-l. I used
And then-
file.
So instead of WC to get the
Oh, yeah. So that was in ls-l. One of the things that ls-l shows you is the file size, in addition to the permissions and the ownership and all that stuff. Yeah, so ls-l gives you a lot. Okay.
And also, the human reader,
Oh, that's cool. Yeah, so a lot of these Linux commands, if you give it an option of H, it kind of presents its information in a more human readable form. And so in this case, instead of showing us 1,596 characters, it's showing, it has 1.6K of data. So it's more human readable shorthand. Okay, so let's go back to our commands here. So the less command we know, this is the thing that the manual pages use, right? So let's go back and run less on the file full.c. So this is the paging viewer that we know. It shows us the first page and it stops. And so I can hit the space bar and see the next page and so on. If you're actually interested in reading the contents of a file, this is a great way to go. Less has some really nice features also. You can go down a line at a time with the enter key. You can go back up the file backwards using a different character, Control Y. You can use the slash character to go search for stuff. Like if I want to search for the string int, it highlights that string that I've searched for. So the less program, take a look at the man page on less. It has a ton of features that, you know, I'm sure I use 10% of its capabilities in my everyday work. And then I use the Q, letter Q, to get back out. So that's less. Okay, here's a bunch of other great commands, head and tail. Let's say you only want to look at the top few lines of a file. That's what head is for. It shows you the head of the file. And so by default, head shows you the first 10 lines, full.c. And so there's the first 10 lines. Similarly, tail shows you the tail end, just the bottom end of the file. So it's really convenient when you don't want to look at the whole file. You just need to glance at the beginning of the file to figure out what's in it. Maybe you'll have a comma-separated data file or a tab-delimited data file, and you really just want to see the first few lines to see what's there. So head's perfect for that. So if we look at the man page for head, you see that it too has a bunch of options. So I can tell it, you know, so by default it shows me 10 lines, but I can use the -n flag to tell it how many lines do I want. So I could say head-n3 full.c, for example, and it just shows me 3 lines instead of 10. Or you can ask for 1,000, you can ask for 1,000,000, right? You've got a lot of flexibility there. Tail is the same sort of thing. You can say, by default, it'll show me the last 10 lines, but I can say, just show me the last 1 line, or the last 20 lines. Another great program is called grep. So grep is a tool that allows you to search for a pattern within a file. And so it looks like this. You say grep, and you give it the pattern. Let's see, let's look for, let's less our full.c. We can see that full.c includes some header files. And let's say we want to figure out what are all the include files that this particular piece of code includes. So what we can do is simply grep include full.c. So we're telling the grep pattern, this is a character string pattern, and we want to find all the lines that match that pattern in this file. And so there's a list of all the occurrences of the word include within that file. So it's a tremendously useful tool if you're looking for a particular word in a document, or a particular character string in a piece of software, or a particular character string in a big data file or something like that. grep is a tremendously powerful tool that can look at all kinds of patterns from any number of files that you want to see. So you're not limited to just a single file. Let's see. We've got how many different C files here? We've got program.c, we've got new.c, we've got full.c. Let's go find the include statements in all of those files. So I can say grep include from full.c, from new.c, and from program.c. So now I'm searching multiple files for that same pattern. And so now when I do that, you'll see that here are the occurrences of include from full.c, and it says full.c over on the left. Here are the occurrences of include in new.c, and here are the occurrences in program.c. And so you can give grep multiple files to go and search. For that, you'll look for a single pattern in one or more output files. You can. So there are things in the shell called wildcards. And wildcards are patterns that the shell uses to represent multiple files. So we'll get, let's see, not sure where that comes. That comes soon. We might as well talk about that right now. In Linux, there are a bunch of special characters that we use to represent multiple files. One of them is the star key, asterisks, that's capital 8. So star.c, for example, is a pattern that represents any file that ends with .c. So, and it's not just grep that uses that pattern. Every Linux command uses patterns like that, because that's something that the shell does for us before it starts the grep program. So we can say, for example, ls full.c, new.c, program.c. Okay, so we've listed out those 3 specific files. Or alternatively, we can say ls space star.c. So that's a wildcard, a shorthand notation for any file whose name ends with .c. And it lists out the same thing. Okay, so you can use those combinations of commands and patterns to do all kinds of great stuff. So you could say grep include from star.c, or you could say grep include from star. So star is a pattern that matches anything. And so it searches all the files in the directory and finds anything with an include and spits it out. Okay, so I encourage you to take a look at the man page for grep. Grep has a gazillion different options. It can do things like search in a case-insensitive way or search in a case-sensitive way. It can look for specific classes of characters, just digits or just letters, all kinds of things. So take a look at that page and you'll be astonished at what it can do for you. Okay, let's touch on the rest of these commands and then we'll, wildcards is the next thing. Let's see if we can get through these next 2 slides before we call it a day. So VI is a program, a command on Linux for editing files. It's an incredibly powerful text editor, but it is really quite counterintuitive to use. And for a number of computer users, they're finding that it's really kind of an obstacle to getting their work done in Linux. And we're going to opt this time around for a different editor called Nano. And so we're going to talk about that next time. I've handed out a cheat sheet on commands to use in the VI editor, but we're really not going to go into it very much. And instead, next time we're going to talk about Nano, how to use it, and what you can do with it. So it's enough about VI. So the CP command we already talked about. Use that to copy those files into your directory. The way you typically use it is CP space file 1, file 2. So that makes a copy of file 1 and puts it in a new file called file 2. But you can also use CP with directories. So you can copy a file and put it into a directory. You can copy a directory and put it into another location. So let me illustrate. Okay, so here we are in my intro Linux directory. I'm going to make a directory called test dir. Okay, so now when we ls, we can see test dir over here, highlighted in blue. And if we cd to test dir and look around, there's nothing in it. So it's a brand new empty directory. Okay, so I'm going to go back up. So now I'm in our intro Linux 1. And if I say, let's copy space, I'm going to copy this file over here, aliases.txt. I'm going to copy aliases. I'm using my tab completion, so I don't have to type the whole thing out. And I'm going to now copy that into test dir. So when I do that, okay, the shell comes back, doesn't say anything, so I'm assuming it works. So now when I cd into the test directory and ls, I can see aliases.txt. So this is a form of the copy command where I copied a regular file from where it was into a new directory. Okay, so you can copy files from one name to another, make a new regular file that has the same contents, but a different name. So let's go back up and try that. So here, whoops, pwd. Okay, I'm in my intro Linux 1 directory. I'm going to copy, this time I'm going to copy the aliases.txt, and I'm going to call this Brett's file. Okay, so it did that. If I type ls-l, I can see there's an aliases file, and now there's a brand new file that was just created at 1459 called Brett's file. You can see the size of the file is identical. The ownership and all that is identical. Okay, if I head aliases.txt, I see a few, looks like some slurm and alias commands in there. If I head Brett's file, I see the exact same thing. So this is a way to copy a regular file from one name to another name within the same directory. Okay, so you saw that we can copy whole directories around with the cp-r. We can copy regular files around with just a regular cp command. So it's an incredibly flexible tool. It's an incredibly useful thing. Yes? You can. So there's an mv command. So mv moves can be used. MV is very similar. It can either move a file from one name to another name, essentially the same file with a different name in the same directory. So I can move Brett's file to Wim's file. Okay. So it's the same contents, I just changed its name. I can also move Wim's file from its current location into a different directory. So it contains the same contents, the same name, but now it's in a different place. So you can use it to move things around or rename them. So move is a really useful thing. So that's copy and move. Now there's a command called touch, and it's kind of a strange thing. What touch is really good at is creating new empty files. And I'll show you some examples next time of where that's a useful thing. Touch also gives you the ability to alter some file contents. So let's do an ls-l. We can see Wim's file down here at the end. I'm going to create a new file. I'm going to say touch space foo. Okay, I'm going to create a brand new file called foo that doesn't formerly exist. So now when I use ls-l to look at it, I see that it just got created and that its file size is 0. So it's a new and empty file. Okay, sometimes that's a really useful thing just to keep as sort of a timestamp, essentially. So you can create a file that has the current system date and time of when it was created. Okay, so we have run out of time. So we will pick up here where we left off next Thursday at 1 o'clock. In the meantime, you're welcome to log in with your temporary account or your unit, play with these commands, play with these files. You can't do anything, you can't do any damage to the system, so go have fun. If you run into questions, send us an email and let us know.
Maybe one remark on touch that it also change if the file exists, it will change the timestamp.
That's a really
very useful thing. For instance, like what I'm now saying, I maybe should say, but like you have some files that will be deleted from scratch.
Dude, don't say that.
And change the timestamp, you know? Say, okay, they have a new timestamp of when you touch the file.
That's right. So if you look, this file was created at 1502. I'm sorry I've kept you late. Now I'm going to use the touch command again. And now we look again, and now it's the time on this file is 1503. So we've updated its modification time, even though we haven't done anything to it. Okay. All right. Thank you for coming. We'll see you next time. Yes. It's an empty file. so it's something with no content. It has no extension. It's simply a placeholder on the file system where some content could go, but at the moment there's nothing in it. Can you do what? Sure. Yeah, you have the right permission in your directory, so you can replace it. Yeah, apparently, yeah, so a file doesn't have to. It has to do with kind of the underlying structure of the Unix file system, how when the file is created and it's linked to a directory, as long as that file is linked to the directory, it goes. And it doesn't even have to contain anything, just like this. As soon as you remove that link between the file and the file system, that space is thrown away and gets reused. So that's kind of that link between the file and the directory it's in is the thing that keeps that file around. Yeah. So next time, we're going to play with the remove image, which unlinks files from your folders. And that's how you get rid of stuff. Cool. Thank you. Thanks a lot. See you next time. Yeah.
I know where to. I learned these things by, trial and error by looking at other people's scripts. But I need to run a script